Oh, hi there. Thanks so much for showing up for your math learning. It's me. We didn't get this lesson recorded for some reason, so we're going to give her another shot. With rational equations, it's like taking a rational function, but we're going to have it, rather than be a function, we're going to be equal to something, or maybe equal to another function, in which case we're going to be looking for the value of x that would make that true, if they exist. Okay, so we could have multiple or solutions. We could have no solutions. We could have as many as the degree of the various rational functions. So here's like the steps. We're going to see the steps put in action. One strategy is to put them all over the same denominator when we have these rational functions. Another is to multiply through so you have no denominators. If you use the second method, it's a little trickier algebraically. You also need to be sure that you're not running into some restrictions. So I'll talk through both methods here. And then we solve the equation. Okay, let's go. All right, so in this example here, if we have this example, we are going to be looking at, what value of a makes this true. So I'm noticing that we have this a on the bottom. If I were to multiply this one by 5 on 5, and I'm just going to rewrite the whole equation. This is crazy. I don't want to jam it in. A plus 1 over 5a minus 1 over a is equal to 1. And then I'm like, I want to create a common denominator here. So I'm going to multiply this by 5 over 5. And then I might as well, while I'm at it, create a common denominator on the other side. Multiply by 5a over 5a. And that gives me the next line. A plus 1 minus 5 all over 5a is equal to 5a over 5a. Now I can do this cool thing. I can multiply both sides by 5a. So do I get 25a squared there? No. This cancels that, and this cancels that. But when I'm canceling away this a, I need to remember that denominators cannot be 0, so a cannot be equal to 0. No sure restrictions. All right, that gives us the next line, that a plus 1 minus 5 is equal to 5a. Subtract a from both sides gives you minus 4 equals 4a. And then dividing both sides by 4 gives you minus 1 equals a. There's your solution. What do you suppose you do next? Substitute it into the original equation is a great choice. Minus 1 plus 1 all over minus 5 minus 1 over minus 1. Does that indeed equal 1? Well, this is 0. That's gone. And in my experience, negative 1 divided by negative 1 is indeed 1. So this checks out. But you might want to know, well, what if I want to save a lot of time and energy? What would I do then? And I would say, do it this way. Just multiply both sides by 5a straight away. You're going to get rid of your denominator in your first line. We have to distribute it in, so it's going to multiply this, and it's going to multiply this. So I just need to be careful here. And if I multiply this one, that's going to cancel. The a is going to cancel there and leave me 5, giving me my first line. A plus 1, not multiplied by 5a, because I already canceled its denominator. It has been multiplied. Minus 5 is equal to 5a, and then we just get that line that much easier, that much quicker. Okay, next example. Suppose we have one like this. Well, my first step might be to write it out again. X plus 9 over x plus 4. The fact that 9 and 4 are both squares has nothing to do with this problem. 2 over x. Okay, so now I'm just going to go ahead and create a common denominator. This one, maybe I'm going to multiply it top and bottom by x, because I see that we have a factor x on that side of the equation. And over here, we have this factor x plus 4 that we need to inject on that side. So we're going to multiply by x on 4 plus x on 4. Okay. In all cases, we apply the distributive property. So over here, we get x squared plus 9x over x squared plus 4x equals, over here we common denominator, x squared plus 4x, and then over there it's 2x plus 8. Okay, distribute this in. Then, you guessed it, we're going to multiply both sides by x squared plus 4x. That will eliminate our denominator on that side. And if we do that over here, multiplied by x squared plus 4x, it eliminates the denominator on that side. What a delight. Then we get the much tidier, much more grade 10 equation that we can then solve. X squared plus 9x equals 2x plus 8. In other words, x squared plus 7x minus 8 equals 0. And then this factors into x plus 8 times x minus 1 equals 0, giving you the solution set x equals 1 or x equals minus 8. There's your solutions. And what do? Plug them into the original equation and solve. So we believe x is equal to minus 8 or 1. So let's try minus 8. Minus 8 plus 9 over minus 8 plus 4 equals 2 over minus 8. Well, it sure does. This is 1 over minus 4 is equal to 1 over minus 4. Good. Now let's just change our substitution. See what we would get if we changed this. Okay, if we put in 1 for x, we get 10 over 5, which is indeed 2 over 1, and that's also true. Great. What's the faster way? The way that saves much pen ink? Well, we're just going to multiply here by x. Sorry, we're going to multiply by x times x plus 4 on both sides. And if we multiply by both denominators, we just multiply by what we know the common denominator is going to be, then this will cancel this, and I distribute x in here, and this will cancel this, and I distribute x plus 4 against 2. So that would right away give me x squared plus 9x equals 2x plus 8. And you'll recall that's what we started with. Last problem. Let's keep going. More examples. All right, this one is good. Can't wait to rewrite this one so that I have space. 4 over k squared minus 8k plus 12. I have this funny feeling that that's the same thing as k. Minus 2 times k minus 6. Okay, so I'm going to write it that way. K minus 2 times k minus 6 equals k over k minus 2 plus 1 over k minus 6. Okay, so now I'm going to go ahead and create this common denominator here, because I love spending a lot of pen ink. This ink's free. It's digital. I think it's free. If I'm paying per line, then I owe a lot of money. Okay, and then I just simplify that. So I have 4 over k minus 2, k minus 6 equals, distribute k squared minus 6k all over k minus 2, k minus 6. Plus 1 distributed in here, so that's plus k minus 2. Okay, and now we simplify. So this is 4 over. I can't. I just gotta get rid of it. Multiply both sides by k minus 2, k minus 6. K multiply here. K minus 2, k minus cancels, 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 cancels. Don't need to write it anymore. Why are we carrying around these denominators when we clearly don't need them? No reason to. Just get rid of them. 4 is equal to k squared minus 5k, because these are like terms and we collect them, minus 2. So that gives us 0 is equal to k squared minus 5k minus 6. And that means 0 is equal to k minus 6 times k plus 1. And k equals minus 1 or 6. There's your solutions. Check them. In the original, without any factoring, just to check any errors, find any errors. So let's try k equals minus 1. So we'll have 4 over minus 1 squared minus 8 times minus 1 plus 12 is equal to minus 1 over minus 1 minus 2 plus 1 over minus 1 minus 6. Let's see what we get. This is like saying 4 over 21 is equal to 1 over 3 plus 1 over 7. And if I add those fractions together, I get this is equal to 7. Oh, this is minus 1/7. Minus 1/7. Good. 7 over 21 minus 3 over 21, which indeed equals 4 over 21, which is what we wanted. Good. Now let's try k equals 6. K equals 6. So k goes there and there and there. Oh, hey oh. This is why you check your answers. Can k be minus 6? No. So k is not 6. So we have k is equal to minus 1 and that's it. K equals minus 1 only. Because k is not equal to 2 or 6. Okay, so there. That's our only solution. Because over here we get a 0 over 0. So we're not allowed that. All right. And then what's the easier way? This one I kind of want to show you like step by step-ish because it can be tricky here. Let's try this one. If I'm going to go ahead and multiply this one by k minus 2, k minus 6 on both sides, I have to multiply the whole side by k minus 2, k minus 6. Okay? What that's going to mean is, here it just cancels, but of course k cannot be equal to 2 or 6 because that would create a 0 in the denominator. We can't multiply both sides of an equation by 0 and be doing anything sensible. So, I'm looking for exceptions, but I can't think of any off the top of my head. Okay, but here, when we multiply this in, let's actually write this side out a little bit. K over k minus 2 multiplied by, because this whole thing multiplies this, and this whole thing multiplies this, right? And so it's going to have different cancellations in both cases. When we multiply here, you don't need to write out this step that I'm showing you if you're really solid. Oops, that was supposed to be a 6. So what happens here is that this cancels that, and we distribute the k in that way. So we end up with k squared minus 6k. And then here, this one cancels this, and we distribute that one in. So it's like the leftover factor stays. So plus k minus 2. And you'll recall that's the same thing that we had on that side of the equation. Good. Okay, so that's how those do.
Can I go ask with the other question?
Yeah. All right, so now this one. Again, I noticed that we're going to need to create a common denominator. I'm going to do it my way. I'll show you what it would look like to solve this problem. I'm going to bracket this whole thing, multiply by x plus 2 times x minus 3. Of course, x cannot equal minus 2 or 3. And then over here, I'm going to have to multiply by the same thing, x plus 2, x minus 3, because I'm just using this multiply both sides by the same thing strategy. So on this side, I get those cancel, and then after we've done that, we're going to have over here 3x times x is 3x squared, because we're distributing here. 3x times 2 is 6x. 1 times x is x. And 1 times 2 is 2. That's what's left over on that side. But over here, the x plus 2 cancels this one, and I have to distribute this. Okay, so there I get x squared minus 3x. And over here, this one cancels, and I'm distributing this. So that's a FOIL. So there I have plus x squared plus 7x, and then plus 2x plus 14. And then I just collect my like terms and solve this quadratic. Let's go. That's going to give us 2x squared plus 4x, plus 6x, my apologies. 6x plus 14 equals 3x squared plus 7x plus 2. Throw it all to one side. 0 equals x squared plus x minus 12. 0 equals x plus 4 times x minus 2, 3. So x equals minus 4 because, that's fine. Because x cannot equal 3. So this is our lone and only solution. Then we sub it back in and solve and find out that's true, and that's great. So thanks for showing up for your learning. I hope this was useful as a recap, and any questions, find me at my many lunch hours of availability and in class. Bye.